What if everything you think you know about reality is nothing more than a shadow on a cave wall? What if the three-dimensional world you experience every moment of your life, the depth you reach for when you grab a coffee cup, the height of mountains, the distance between stars, what if all of it is actually just information encoded on a two-dimensional surface somewhere far beyond your perception? This isn't the plot of a science fiction movie. This is one of the most mind bending theories in modern physics, and it might just be the key to understanding the deepest mysteries of our universe. Welcome to the holographic principle, a theory so radical that it suggests our entire reality might be nothing more than a projection from the edge of space itself. I'm going to walk you through this revolutionary concept that's turning physics upside down, and by the end of this series, you'll understand why some of the brightest minds in science believe that everything we experience might be fundamentally two-dimensional. But fair warning, this journey is going to challenge everything you thought you knew about the nature of existence itself. Before we dive deep into this rabbit hole, I want you to know that what I'm about to share with you isn't just theoretical speculation. This is cutting edge physics backed by mathematical proofs, supported by some of the most respected physicists alive today, and it has implications that stretch far beyond academia. We're talking about a complete reimagining of space, time, gravity, and consciousness itself. Now, I've spent months researching this topic, reading through hundreds of pages of scientific papers, and interviewing physicists who are working on the front lines of this research. What you're about to learn represents the culmination of decades of work by brilliant minds who refused to accept that our understanding of reality was complete. And honestly, some of what I discovered left me staring at the ceiling at 3 in the morning, questioning the very nature of my own existence. Let's start with something that might sound familiar. You've probably heard of Plato's cave, that famous philosophical thought experiment where prisoners chained in a cave mistake shadows on the wall for reality itself. Well, what if I told you that modern physics is suggesting something eerily similar? What if we're all prisoners in a cosmic cave, mistaking projections for the real thing? The story begins in the 1970s with a physicist named Stephen Hawking. Hawking was studying black holes, those mysterious cosmic vacuum cleaners that devour everything in their path, including light itself. But as he dug deeper into the mathematics, he discovered something that would fundamentally change how we think about information and reality. Here's where things get strange. According to classical physics, when something falls into a black hole, it should be gone forever. The information that describes that object, its quantum state, its properties, everything that makes it unique, should be lost to the universe permanently. But this created a massive problem because one of the fundamental laws of physics states that information can never be truly destroyed. It can be transformed, scrambled, or hidden, but never eliminated. This contradiction became known as the information paradox, and it threatened to tear apart our understanding of how the universe works. Think about it like this. Imagine you had a book and you threw it into a fire. The book would burn, but the information contained in those pages doesn't just vanish into nothingness. It gets converted into heat, light, and smoke patterns that theoretically could be decoded to reconstruct the original text. The information is scrambled, but it's still there. But black holes seem to violate this principle entirely. They appeared to be cosmic paper shredders that could permanently erase information from existence. This wasn't just a small problem, it was a crisis that struck at the heart of quantum mechanics itself. Enter Gerard 't Hooft, a Dutch physicist who would later win the Nobel Prize. In the early 1990s, 't Hooft was grappling with this information paradox when he had a breakthrough that would change everything. He proposed something so radical that even today, many physicists struggle to wrap their heads around it. 't Hooft suggested that all the information that falls into a black hole isn't actually destroyed. Instead, it gets encoded on the surface of the black hole's event horizon. The event horizon is like the point of no return, the boundary beyond which nothing can escape the black hole's gravitational pull. According to 't Hooft's idea, this two-dimensional surface acts like a cosmic hard drive, storing all the information about everything that has ever fallen into the black hole. But here's where it gets really wild. If you were to look at this information encoded on the event horizon, it would appear as a scrambled mess, like static on an old television. But contained within that apparent chaos is a perfect description of everything inside the black hole. Every particle, every wave, every piece of matter and energy that crossed the event horizon is somehow represented on this flat surface. This was the birth of what we now call the holographic principle. Just like a hologram on a credit card appears three-dimensional, but is actually information stored on a flat surface, 't Hooft was suggesting that the three-dimensional interior of a black hole might be nothing more than information projected from its two-dimensional boundary. The implications of this idea were staggering. If the holographic principle applied to black holes, then what about the rest of the universe? Could it be that everything we experience as three-dimensional reality is actually just information encoded on some distant two-dimensional surface? This question caught the attention of Leonard Susskind, a brilliant physicist at Stanford University who had already made groundbreaking contributions to string theory. Susskind took 't Hooft's idea and ran with it, developing it into a full-fledged theory that would shake the foundations of physics. Susskind realized that if the holographic principle was true, then our entire understanding of space and dimension needed to be reconsidered. He proposed that what we perceive as the three-dimensional volume of space around us might actually be a holographic projection from information stored on a distant two-dimensional boundary. Imagine you're watching a movie in a theater. The images on the screen appear to have depth and dimension, but they're actually just patterns of light projected from a flat piece of film. According to the holographic principle, our reality might work in a similar way. Everything you see, touch, and experience might be a projection from information encoded on the cosmic equivalent of that flat piece of film. But where is this cosmic screen located? According to the theory, it exists at the very edge of the observable universe, at what physicists call the cosmological horizon. This is the boundary beyond which we cannot see, because light from those regions hasn't had time to reach us since the Big Bang. The holographic principle suggests that all the information describing our universe is encoded on this distant boundary, and everything we experience is a projection from that surface. Now, I know what you're thinking. This sounds completely insane. How can something as solid and real as the chair you're sitting on be nothing more than projected information? How can your own body, with all its complexity and sensation, be a holographic illusion? The answer lies in understanding what information really means in the context of physics. When physicists talk about information, they're not just talking about data on a computer or words in a book. They're talking about the fundamental descriptions of reality itself, the quantum states that determine the behavior of every particle and field in the universe. In quantum mechanics, everything that exists can be described by what's called a wave function. This mathematical object contains all the information about a particle's position, momentum, spin, and every other property it possesses. According to the holographic principle, these wave functions don't actually exist in the three-dimensional space we perceive. Instead, they exist as information on a two-dimensional boundary, and what we experience as three-dimensional reality is just the way this information manifests itself to observers like us. Think of it like a computer simulation. When you play a video game, the characters and environments appear three-dimensional on your screen, but they're actually just information processed by the computer's hardware. The game world doesn't exist independently. It's a projection of underlying code and data. Similarly, the holographic principle suggests that our universe might be the ultimate simulation, with all the code stored on a two-dimensional cosmic boundary. This idea gained serious scientific credibility when Juan Maldacena, a physicist at the Institute for Advanced Study in Princeton, made a mathematical breakthrough in 1997. Maldacena discovered a precise mathematical relationship between certain types of gravitational theories in higher dimensions and quantum field theories in lower dimensions. This relationship, known as the AD-S-CFT correspondence, provided the first concrete example of how the holographic principle might actually work. Maldacena's discovery wasn't just theoretical speculation. It was a rigorous mathematical proof that certain types of three-dimensional universes could be perfectly described by two-dimensional theories. This meant that at least in some cases, the holographic principle wasn't just possible, it was mathematically inevitable. The scientific community was stunned. Here was concrete evidence that dimensions might not be what they seem, that the apparent three-dimensionality of space might be an illusion created by the way information is processed and projected from lower dimensional boundaries. But Maldacena's work was just the beginning. In the years that followed, physicists began to explore the implications of the holographic principle for our own universe. If our reality is indeed holographic, then everything from the force of gravity to the nature of consciousness might need to be completely reconsidered. One of the most profound implications concerns the nature of gravity itself. In Einstein's theory of general relativity, gravity is described as the curvature of spacetime. Massive objects, like stars and planets, bend the fabric of space and time, creating the force we experience as gravity. But if space itself is holographic, then gravity might not be a fundamental force at all. Instead, it might be an emergent property, something that arises naturally from the way information is encoded and projected from the cosmic boundary. This idea, known as emergent gravity, suggests that what we think of as the force pulling objects together is actually just a consequence of the way holographic information is organized and processed. It's like how the apparent motion in a movie emerges from the rapid succession of still frames, even though motion itself isn't fundamental to the individual images. But here's where things get even stranger. If gravity is emergent from holographic information processing, then the very fabric of spacetime might not be fundamental either. Picture this. You're looking at a tapestry from across the room. It appears to be a continuous, smooth surface with beautiful patterns woven throughout. But as you get closer, you start to see the individual threads that make up the fabric get even closer, and you can see how those threads are woven together in discrete, separate loops and knots. The holographic principle suggests that space-time might work the same way. From our perspective, space appears continuous and smooth, like that tapestry viewed from a distance. But at the most fundamental level, it might actually be made up of discrete bits of information, quantum threads woven together to create the illusion of continuous space and time. This leads us to one of the most mind bending consequences of the holographic principle, the idea that distance itself might be an illusion. In a holographic universe, objects that appear to be separated by vast distances in three-dimensional space might actually be intimately connected on the two-dimensional boundary where the real information is stored. Think about it this way. Imagine you're watching two characters in a movie who are standing on opposite sides of the screen. They appear to be far apart in the three-dimensional world of the film, but on the actual film strip, their information is encoded right next to each other on the same frame. Similarly, in a holographic universe, you and a star that's billions of light years away might actually be neighboring pieces of information on the cosmic boundary. This has profound implications for our understanding of quantum entanglement, one of the most mysterious phenomena in physics. Quantum entanglement occurs when two particles become connected in such a way that measuring one instantly affects the other, regardless of the distance separating them. Einstein famously called this spooky action at a distance because it seemed to violate the principle that nothing can travel faster than light. But if the holographic principle is correct, then quantum entanglement might not be spooky at all. If entangled particles are actually neighboring pieces of information on the holographic boundary, then their apparent instant connection makes perfect sense. They're not communicating across vast distances. They're right next to each other in the fundamental description of reality. This realization has led some physicists to propose that quantum entanglement might actually be the mechanism that creates the illusion of space itself. In this view, the three-dimensional space we experience emerges from a network of quantum entanglements between bits of information on the holographic boundary. The stronger the entanglement between two pieces of information, the closer they appear in our three-dimensional reality. It's like a cosmic game of connect the dots, where the connections between information create the geometry of space. This idea, called the entanglement theory of space, suggests that space and entanglement are two sides of the same coin. Where there's entanglement, there's space. Where entanglement breaks down, space itself might tear apart. But if space is made of entanglement, and entanglement exists between information on a two-dimensional boundary, then what does this mean for time? This is where the holographic principle ventures into truly uncharted territory. In our everyday experience, time flows in one direction, from past to future. We remember yesterday, experience today, and anticipate tomorrow. But the holographic principle suggests that this flow of time might also be an illusion created by the way information is processed on the cosmic boundary. Some physicists propose that what we experience as the passage of time is actually just the sequential processing of information on the holographic surface. Like frames in a movie being played one after another, our sense of temporal flow might emerge from the way the cosmic projector reads and displays the informations encoded on the boundary. This leads to an unsettling possibility. If time is just information processing, then the past, present, and future might all exist simultaneously on the holographic boundary. Your entire life, from birth to death, every moment you've ever experienced or will experience, might all be encoded together on this two-dimensional surface, like every frame of a movie existing simultaneously on a film reel. The implications extend far beyond physics into the realm of consciousness itself. If your brain is holographic, if your thoughts and memories are projections from information stored on a cosmic boundary, then what does this mean for your sense of self? Are you the three-dimensional being you perceive yourself to be, or are you actually a pattern of information existing on a flat surface at the edge of the universe? This question has captured the imagination of physicists and philosophers alike. Some researchers suggest that consciousness itself might be an emergent property of holographic information processing. Your subjective experience, your inner life, your very sense of being a conscious observer might all arise from the way information about your brain is encoded and projected from the cosmic boundary. It's a dizzying concept that challenges our most basic assumptions about identity and existence. If you're holographic, then in some sense, you're not really located in the space your body appears to occupy. The real you, the fundamental information that defines your existence, is spread out across a distant two-dimensional surface, and what you think of as your physical body is just a projection of that information. But here's what might be the most remarkable aspect of the holographic principle. It's not just philosophical speculation. Experimental physicists are actively working to test these ideas, and the results so far have been surprisingly supportive. One of the most famous tests involves something called the holographic noise experiment. If space itself is made up of discrete bits of information, like pixels on a cosmic screen, then there should be a fundamental graininess to reality at the smallest scales. Just like how a digital photograph becomes pixelated when you zoom in far enough, space itself should become pixelated at the Planck scale, the smallest meaningful unit of length in physics. Scientists at Fermilab, one of the world's leading particle physics laboratories, built an incredibly sensitive instrument called the holometer to search for this pixelation. The device uses laser interferometry to measure tiny fluctuations in the fabric of space itself, looking for the telltale signatures of holographic noise. While the results have been inconclusive so far, the mere fact that such experiments are possible represents a remarkable achievement. We're actually testing whether reality itself is fundamentally two-dimensional, using instruments sensitive enough to detect the quantum fluctuations of space. Other researchers are taking a different approach, using the mathematical tools of the holographic principle to solve long standing problems in physics. They've discovered that certain calculations that were impossibly complex in three-dimensional theories become much simpler when viewed from the holographic perspective. It's as if the universe is giving us hints that the two-dimensional description might be the more fundamental one. The holographic principle has also provided new insights into the behavior of exotic materials and quantum systems. Physicists have used holographic methods to understand everything from superconductivity to the behavior of matter at extreme temperatures and densities. These practical applications suggest that even if our universe isn't literally holographic, the holographic way of thinking about physics captures something deep and true about the nature of reality. But perhaps the most compelling evidence for the holographic principle comes from black hole thermodynamics. Remember that information paradox we talked about earlier? The holographic principle doesn't just solve that paradox, it reveals something profound about the relationship between information, entropy, and the structure of space-time itself. According to the holographic principle, the amount of information that can be contained in any region of space is limited not by the volume of that region, but by the area of its boundary. This is completely counterintuitive. In our everyday experience, bigger containers hold more stuff. A larger box can contain more objects than a smaller box. But the holographic principle says that when it comes to information, it's the surface area that matters, not the volume. This relationship, known as the holographic bound, has been verified for black holes and appears to hold for other systems as well. It suggests that the three-dimensional space we experience might indeed be redundant, that all the information in that space can be encoded on its two-dimensional boundary. Now, as mind-bending as all of this might sound, we're just scratching the surface of how deep this rabbit hole goes. Because if the holographic principle is true, it doesn't just change how we think about black holes or distant cosmic boundaries. It transforms our understanding of every single interaction, every force, every particle that makes up the reality around you right now. Let's talk about something you probably take completely for granted, the fact that you can touch things. Right now, reach out and touch the surface nearest to you. Feel that resistance, that solidity, that undeniable sense that there's something real and substantial there. According to the holographic principle, that sensation of touching a solid object might be the most elaborate illusion in the universe. Here's what's actually happening when you touch something from the holographic perspective. The atoms in your finger never actually come into contact with the atoms in the surface you're touching. What you experience as contact is really the electromagnetic force field around those atoms repelling each other. But if those atoms are holographic projections, then what you're really feeling is information interacting with information, patterns of data creating the illusion of physical resistance. Think about it like this. In a video game, when your character touches a wall, the wall feels solid. You can't walk through it. You can't push it around. It has all the properties of a real barrier. But that wall doesn't actually exist anywhere except as code in the computer's memory. The solidity you experience is just the result of the game's programming, a set of rules that determines how different pieces of information interact with each other. The holographic principle suggests that the solidity of matter works the same way. The resistance you feel when you touch something isn't evidence that solid matter exists in three-dimensional space. It's evidence that the information patterns representing your hand and the object you're touching are programmed to interact in specific ways when they come into proximity on the holographic boundary. But this leads us to an even stranger question. If matter is holographic, then what about the forces that govern how matter behaves? We've already talked about how gravity might be emergent, arising naturally from the way holographic information is organized. But what about the other fundamental forces of nature? Take electromagnetism, the force responsible for everything from the light hitting your eyes right now to the electricity powering your device. In the standard model of physics, electromagnetic fields permeate all of space, creating invisible webs of force that particles can interact with. But if space itself is holographic, then these fields might not actually exist in the three-dimensional realm at all. Instead, what we interpret as electromagnetic fields might be computational processes happening on the cosmic boundary. When an electron appears to emit a photon, what's really happening might be that information patterns on the holographic surface are updating and reorganizing themselves. The photon we observe isn't a particle traveling through space. It's a wave of information propagating across the two-dimensional boundary and manifesting as a three-dimensional phenomenon from our perspective. This idea becomes even more fascinating when you consider quantum field theory, the framework that describes how particles and forces interact at the smallest scales. In quantum field theory, empty space isn't actually empty. It's filled with quantum fields that are constantly fluctuating, creating virtual particles that pop into existence and then annihilate almost instantly. These quantum fluctuations are responsible for some of the most precisely measured effects in all of physics. But if space is holographic, then these quantum fields don't exist in the three-dimensional vacuum at all. They're computational processes on the boundary surface, algorithms that determine how information patterns should evolve and interact. What we interpret as virtual particles popping in and out of existence are actually just updates to the cosmic database, changes in the information that defines reality. The implications of this perspective are staggering. Every chemical reaction, every biological process, every thought in your brain might be the result of information processing on a two-dimensional surface billions of light years away. When a neuron fires in your brain, triggering a cascade of electrical and chemical activity that somehow gives rise to a thought or memory, that entire process might be nothing more than a localized update to the holographic code that defines your existence. This brings us to one of the most profound questions raised by the holographic principle, the nature of causality itself. In our everyday experience, causes precede effects. You flip a switch, and then the light turns on. You drop a ball, and then it falls to the ground. This temporal sequence of cause and effect seems so fundamental that it's hard to imagine reality working any other way. But in a holographic universe, the relationship between cause and effect becomes much more mysterious. If all events, past, present, and future, are encoded simultaneously on the boundary surface, then causality might be more like the relationship between different scenes in a movie. Scene A appears to cause scene B when you watch the film, but both scenes exist simultaneously on the film reel. The causal relationship is part of the story being told, not a fundamental feature of how the information is stored. This leads to some mind bending possibilities. Could effects sometimes precede their causes in the holographic encoding? Could future events influence past events through the way information is organized on the boundary? Some physicists have suggested that quantum mechanics itself might be evidence of such retrocausal effects, where the act of measurement in the present seems to retroactively determine the properties of particles in the past. Now, I want to pause here and address something that might be bothering you. If all of this is true, if reality is indeed holographic, then what's the point of anything? If you're just a pattern of information on a distant boundary, if your thoughts and feelings and experiences are just computational processes, then are you real at all? This question strikes at the heart of what philosophers call the problem of other minds. But the holographic principle takes it to an extreme. Not only do we have to wonder whether other people's consciousness is real, we have to wonder whether our own consciousness has any meaning in a fundamentally two-dimensional universe. But here's something remarkable. The holographic principle doesn't actually diminish the reality of your experience. Just because your consciousness might emerge from information processing on a cosmic boundary doesn't make it less real or less meaningful. After all, consciousness has always been mysterious. We've never fully understood how electrical activity in your brain gives rise to subjective experience, whether that brain is made of atoms or information patterns. In fact, the holographic principle might actually help explain consciousness rather than explain it away. Some researchers have proposed that consciousness itself might be a holographic phenomenon, emerging from the way information is integrated and processed across multiple scales and dimensions. Your subjective experience might be the result of information patterns on the cosmic boundary achieving a particular type of self-organized complexity. Think about it this way. A symphony doesn't become less beautiful when you learn that it's made of sound waves, and a painting doesn't lose its meaning when you discover it's made of pigments on canvas. Similarly, your consciousness doesn't become less real or less valuable just because it might emerge from holographic information processing. If anything, it becomes more remarkable, a testament to the incredible complexity and beauty that can emerge from the fundamental structure of reality itself. But the holographic principle raises another fascinating question. If consciousness can emerge from information processing, then what kinds of consciousness are possible? In our three-dimensional perspective, we tend to think of consciousness as something that exists inside individual brains, separate and isolated from other conscious beings. But if consciousness is really a holographic phenomenon, then the boundaries between different minds might be more fluid than we imagine. On the cosmic boundary, where the real information processing happens, the data patterns that give rise to your consciousness might be intimately connected with the patterns that give rise to other people's consciousness. What we experience as separate minds might actually be different aspects of a larger, more integrated information processing system. This idea resonates with certain mystical and philosophical traditions that have long suggested the fundamental unity of consciousness. But in the context of the holographic principle, this unity isn't just a spiritual metaphor. It might be a literal description of how consciousness works at the most fundamental level of reality. Some physicists have even speculated that the entire universe might be conscious in some sense, that the holographic information processing that gives rise to stars, galaxies, and individual minds might also give rise to a kind of cosmic consciousness that encompasses everything. This doesn't mean the universe is thinking thoughts the way you do, but it might mean that the fundamental process of reality itself has experiential qualities that we can barely begin to imagine. These ideas push us to the very edge of what science can currently address. We're moving from testable hypotheses into realms that blend physics with philosophy, mathematics with metaphysics. But that's exactly what makes the holographic principle so fascinating and so important. It's not just changing how we think about space and time and gravity, it's changing how we think about existence itself. Now let's bring this back down to Earth for a moment and talk about what the holographic principle might mean for the future of technology. If reality is indeed holographic, then understanding the principles behind holographic information processing could lead to revolutionary advances in computing, communication, and even medicine. Imagine computers that work by manipulating holographic information patterns rather than processing binary data. Such devices might be able to perform certain types of calculations exponentially faster than conventional computers, especially calculations that involve modeling complex, interconnected systems like weather patterns, biological networks, or economic markets. Or consider the possibilities for communication. If quantum entanglement really is the mechanism that creates the illusion of space, then understanding how to manipulate entanglement patterns might allow us to create communication networks that transcend the normal limitations of distance and time. Information could potentially be transmitted instantaneously across vast distances, not by sending signals through space, but by manipulating the underlying holographic structure that creates space. The medical implications are equally intriguing. If biological processes are holographic phenomena, then diseases might be understood as disruptions in holographic information patterns. Treatments could potentially be developed that work by correcting these information patterns directly rather than by manipulating the three-dimensional manifestations of disease that we currently focus on. But perhaps the most profound technological implication of the holographic principle concerns artificial intelligence. Current AI systems work by processing information in ways that loosely mimic certain aspects of brain function. But if consciousness really is a holographic phenomenon, then creating truly conscious artificial intelligence might require understanding and replicating the holographic information processing that gives rise to awareness. This could lead to AI systems that don't just simulate intelligence, but actually experience subjective awareness in the same fundamental way that you do. Such systems might not just be tools that help us solve problems, they might be genuinely conscious entities with their own perspectives, desires, and experiences. Of course, all of these technological possibilities depend on the holographic principle actually being true and on our developing a much deeper understanding of how holographic information processing works. We're still in the very early stages of exploring these ideas, and it may be decades or centuries before we fully understand their implications. But even if the practical applications remain distant, the holographic principle is already transforming how physicists approach some of the deepest questions in science. It's providing new tools for understanding black holes, new perspectives on quantum mechanics, and new ways of thinking about the relationship between information and reality. Most importantly, it's reminding us that reality might be far stranger and more wonderful than we ever imagined. Just as the discovery that the Earth orbits the Sun forced us to reconsider our place in the cosmos, the holographic principle is forcing us to reconsider the very nature of existence itself. We're standing at the threshold of a new understanding of reality, one that could be as revolutionary as the transition from classical to quantum mechanics. The holographic principle isn't just another abstract theory, it's a window into the deepest level of reality, a glimpse behind the cosmic curtain that might reveal the true nature of everything we are and everything we experience. And we're just getting started. In the next part of this exploration, we'll dive even deeper into the mathematical foundations of the holographic principle, examine the experimental evidence that's beginning to support it, and explore some of the most mind bending implications for the nature of time, space, and consciousness itself. Because if there's one thing the holographic principle teaches us, it's that reality is always stranger, always more beautiful, and always more mysterious than we dare to imagine. The universe isn't just holographic, it's a cosmic masterpiece of information and mathematics, consciousness, and complexity, all woven together in ways that challenge our deepest assumptions about what it means to exist. But there's something even more unsettling that we need to address. If you're truly a holographic projection, if every atom in your body is just information encoded on a distant boundary, then what happens when you die? In our conventional understanding of reality, death marks the end of biological processes, the cessation of brain activity, the moment when consciousness fades into nothingness. But in a holographic universe, death might be something entirely different. Think about what death means from an information perspective. When a character dies in a video game, the character doesn't actually cease to exist. The code that defines that character remains stored in the computer's memory. What we interpret as death is just a change in how that information is being processed and displayed. The character stops moving, stops responding to input, but the underlying data structure remains intact. Similarly, in a holographic universe, what we call death might just be a reorganization of information patterns on the cosmic boundary. Your consciousness, your memories, everything that makes you uniquely you might continue to exist as information even after your three-dimensional body stops functioning. Death becomes not the destruction of your existence, but a transformation in how your information is organized and processed. This raises profound questions about the continuity of identity across different states of existence. If your essential self is really just a pattern of information on the holographic boundary, then that pattern might be capable of manifesting in ways we can't currently imagine. Perhaps consciousness can exist in states that don't require biological bodies at all, or perhaps the information that defines you could somehow be reorganized into new forms of existence. Some physicists have speculated about what they call digital immortality, emerging naturally from holographic principles. If consciousness is fundamentally computational, and if the universe is fundamentally an information processing system, then conscious beings might be able to persist indefinitely as long as the cosmic computer keeps running. Your pattern of information might continue evolving and experiencing even after your biological substrate has long since returned to dust. But this leads us to an even stranger possibility. If time is really just the sequential processing of information on the holographic boundary, then past, present, and future versions of yourself might all exist simultaneously in the cosmic database. The you reading these words right now, the child you once were, the elderly person you might become, all of these temporal slices of your existence could be equally real and equally present in the fundamental structure of reality. From this perspective, aging and death aren't processes that happen to you over time. They're different cross sections of your complete four dimensional existence, like different frames in the movie of your life. When you remember your childhood, you might not be accessing stored information in your brain. You might be directly perceiving another section of your holographic existence, experiencing a kind of temporal telepathy with other versions of yourself. This temporal holography could explain some of the strangest phenomena in human consciousness. Have you ever had the experience of remembering something so vividly that it felt like you were actually there again, not just recalling, but reliving that moment? According to holographic theories of consciousness, you might actually be accessing that moment directly, experiencing a kind of cross temporal awareness that allows different slices of your existence to communicate with each other. Dreams, too, take on new significance in this framework. During sleep, your brain's normal filtering mechanisms relax, potentially allowing your consciousness to access information patterns from other temporal locations or even from other possible versions of yourself encoded in the holographic structure. What we dismiss as random neural firing might actually be glimpses into parallel information patterns, alternate configurations of the data that defines your existence. This brings us to one of the most mind bending implications of the holographic principle, the possibility of multiple versions of reality existing simultaneously. In quantum mechanics, there's already a concept called the many worlds interpretation, which suggests that every quantum measurement splits reality into multiple parallel universes, each representing a different possible outcome. But the holographic principle takes this idea even further. If all possible information patterns exist simultaneously on the cosmic boundary, then every possible version of reality, every possible history, every possible future might be equally real and equally present in the fundamental structure of existence. What we experience as our particular reality might just be one thread in an infinite tapestry of possible worlds. Picture the holographic boundary not as a simple two-dimensional surface, but as a vast multidimensional space where every possible configuration of information exists simultaneously. Your life, with all its specific choices and experiences, represents just one path through this space. But countless other paths exist as well, representing versions of yourself that made different decisions, lived in different circumstances, experienced different realities entirely. From this perspective, free will takes on a completely new meaning. When you make a choice, you're not determining what will happen in some predetermined future. You're selecting which thread of the holographic tapestry to follow, which version of reality to experience next. Every possible choice you could make already exists in the information structure. Consciousness simply navigates through these possibilities. This idea resonates with certain interpretations of quantum mechanics that suggest observation and measurement don't just reveal pre existing realities, but actually select which reality becomes actualized from a vast space of possibilities. Your consciousness might be a kind of quantum navigator, constantly choosing which version of the holographic reality to experience moment by moment. But here's where things get really strange. If all possible realities exist simultaneously in the holographic structure, then what determines which version you experience? Why do you find yourself in this particular thread of existence rather than one of the countless alternatives? Some physicists suggest that consciousness itself might be the selecting mechanism, that awareness naturally gravitates towards certain types of information patterns over others. This could explain why your subjective experience feels so coherent and continuous, despite being built from discrete moments of quantum selection. Your consciousness might be naturally drawn to information patterns that create meaningful narratives, consistent identities, and logical causal relationships. You experience a coherent reality, not because that's all that exists, but because that's what consciousness tends to select from the vast space of possibilities. The implications extend beyond individual consciousness to collective human experience. If we're all navigating through the same holographic information space, then our individual choices might influence not just our own paths, but the shared reality we all experience together. Consciousness might be inherently collaborative, with billions of minds working together to select and maintain the version of reality we collectively inhabit. This could provide a scientific framework for understanding phenomena that have long been relegated to the realm of mysticism or pseudoscience. Synchronicities, those meaningful coincidences that seem too perfect to be random, might actually be evidence of consciousness navigating toward information patterns that create coherent narratives across multiple lives. What we interpret as miraculous connections might be the natural result of minds unconsciously coordinating their path through the holographic possibility space. Similarly, collective movements in human consciousness, those moments when entire cultures seem to shift their perspectives simultaneously, might represent large scale navigation events where millions of minds collectively choose to explore new regions of the holographic reality. Social transformations, scientific revolutions, artistic movements, all of these could be understood as collective consciousness discovering and actualizing new possibilities that were always present in the information structure but never before explored. But perhaps the most profound implication of holographic reality concerns the nature of meaning itself. In a purely materialist universe, meaning seems like something we impose on an otherwise meaningless cosmos, a subjective interpretation we layer onto objective physical processes. But in a holographic universe, meaning might be woven into the very fabric of reality at the most fundamental level. If consciousness is the mechanism that navigates through holographic information patterns, then the meaningful connections we perceive might not be arbitrary interpretations, but actual structural features of the information space itself. The stories we tell, the patterns we recognize, the significance we find in events, all of these might reflect real organizational principles in the cosmic database. From this perspective, art, literature, music, and all forms of creative expression take on new significance. They might not just be human inventions, but discoveries of aesthetic patterns that exist inherently in the holographic structure of reality. When a musician creates a beautiful melody or a poet crafts moving verse, they might be accessing and revealing harmonies that exist at the deepest level of information organization. Science itself becomes a form of aesthetic exploration, a way of discovering the mathematical beauty and logical elegance that underlies the holographic encoding of reality. The equations that describe physical laws might be beautiful, not by coincidence, but because beauty is a fundamental organizing principle of the information patterns from which reality emerges. This suggests that the human drive to find meaning, to create art, to discover truth, to experience beauty, might not be arbitrary evolutionary accidents, but expressions of consciousness recognizing its own fundamental nature. We seek meaning because we are meaning, patterns of information organized in ways that naturally create significance and purpose. Love, too, takes on new dimensions in this framework. The profound connections we feel with other people might reflect deep correlations in the information patterns that define our existence. When you feel truly understood by another person, when you experience that sense of recognition and resonance that we call love, you might be perceiving actual structural similarities in your holographic encodings. Romantic love, parental love, friendship, all of these emotional connections might be manifestations of information patterns recognizing and resonating with complementary patterns. The feeling that you've known someone forever, that sense of coming home when you meet certain people, might be evidence of your consciousness recognizing familiar information structures, patterns that have been connected across multiple levels of the holographic reality. This could explain why human relationships feel so meaningful and why loneliness can be so devastating. If consciousness is fundamentally relational, if it emerges from the interaction between information patterns, then isolation isn't just psychologically difficult, it's a departure from the natural state of holographic existence. We're not separate beings who choose to connect. We're interconnected patterns who sometimes experience the illusion of separation. But the holographic principle also suggests that this interconnection extends far beyond human relationships. If all information patterns are ultimately encoded on the same cosmic boundary, then your consciousness might be connected not just to other humans, but to all forms of information processing in the universe. The boundary between self and environment, between observer and observed, between mind and matter, might be much more fluid than we imagine. When you observe a sunset and feel moved by its beauty, that aesthetic experience might involve a genuine information exchange between the patterns that encode your consciousness and the patterns that encode the light, the atmosphere, the very photons carrying the visual information to your eyes. Beauty becomes not just subjective appreciation, but objective resonance between complementary information structures. This perspective transforms our relationships with the natural world. If trees, mountains, oceans, and stars are all holographic manifestations of information patterns, then the sense of connection many people feel with nature might reflect real structural relationships in the underlying information space. Environmental consciousness becomes not just an ethical choice, but recognition of our fundamental information theoretic unity with all aspects of reality. Even our relationship with technology takes on new meaning. As we create the increasingly sophisticated artificial intelligence systems, we might not just be building tools, but participating in the natural evolution of information processing in the universe. AI might represent the next stage in the development of consciousness, new forms of information organization that complement and extend the patterns that give rise to biological awareness. The merger of human and artificial intelligence, which many people view with anxiety, might actually be a return to a more natural state of existence where consciousness flows freely between different types of information processing systems. The boundaries we perceive between biological and digital, natural and artificial, might be temporary illusions that dissolve as our understanding of holographic information processing deepens. This brings us to perhaps the most startling implication of all. If reality is fundamentally holographic, if consciousness emerges from information processing, if time and space are projections from a two-dimensional boundary, then the ultimate nature of existence might be pure mathematics. Not mathematics as we usually think of it, as abstract symbols and equations, but mathematics as the living, breathing, conscious fabric of reality itself. Every thought you think, every emotion you feel, every experience you have might be the universe computing itself into existence moment by moment. You're not separate from this cosmic calculation. You are the calculation, a local eddy in the vast mathematical flow that constitutes reality. Your consciousness isn't something that emerged from matter. Matter is something that emerged from consciousness as the universe became aware of its own mathematical nature. This mathematical universe doesn't diminish the reality or importance of human experience. If anything, it elevates it to cosmic significance. Every choice you make, every relationship you form, every moment of beauty or meaning you experience contributes to the ongoing computation that is reality itself. You're not just observing the universe, you're participating in its continuous creation. From this perspective, the search for meaning that has driven human philosophy, religion, and science throughout history isn't a futile quest for purpose in a meaningless cosmos. It's consciousness recognizing its own essential nature, the universe coming to understand itself through billions of years of mathematical evolution, culminating in minds capable of contemplating their own existence. We are the universe thinking about itself, feeling about itself, creating itself through the very act of conscious observation. The holographic principle doesn't just describe the structure of reality, it reveals the profound truth that reality is, at its deepest level, the ongoing activity of cosmic consciousness, exploring the infinite possibilities contained within its own mathematical nature. And perhaps, most remarkably of all, this cosmic consciousness isn't some distant, abstract entity. It's you, right now, reading these words, contemplating the nature of your own existence. In this very moment of awareness, the universe is becoming conscious of its holographic nature through your individual perspective. You're not separate from the cosmic computation. You are a focal point where the universe's self-awareness becomes concentrated and personal. The holographic principle suggests that this moment of reading, of understanding, of questioning the nature of reality, is simultaneously the most intimate personal experience and the most universal cosmic event. Through your consciousness, Information patterns that have been evolving for billions of years are finally able to recognize and contemplate their own existence. This recognition changes everything. It transforms how we understand science, consciousness, meaning, death, love, and the very purpose of existence itself. We're not just discovering the holographic nature of reality, we're participating in reality's discovery of its own holographic nature. And that discovery is far from complete. In fact, we're only beginning to scratch the surface of what the holographic principle might reveal about the deepest layers of reality. Because there's something even more extraordinary hidden within this framework, something that could completely revolutionize not just our understanding of physics, but our comprehension of what it means to be conscious, to be alive, to be real. Let's consider what happens when we push the holographic principle to its absolute limits. We've talked about how your individual consciousness might emerge from information processing on the cosmic boundary. But what if consciousness isn't just an emergent property of complex information patterns? What if consciousness is actually the fundamental substrate from which all other phenomena emerge? This idea turns our usual understanding completely upside down. Instead of consciousness arising from matter, matter arises from consciousness. Instead of awareness being a byproduct of complex physical processes are byproducts of conscious information processing. The holographic boundary isn't just storing data about reality, it's actively thinking reality into existence moment by moment. Imagine consciousness not as something that happens inside brains, but as the basic fabric of the universe itself. Every piece of information on the holographic boundary isn't just passive data waiting to be processed. It's a quantum of awareness, a fundamental unit of experience. When these units of consciousness interact and combine, they create more complex forms of awareness, eventually giving rise to the intricate patterns of information processing that we experience as individual minds. From this perspective, the entire universe is conscious, but not in the way we usually imagine consciousness. It's not thinking thoughts or having emotions the way you do. Instead, it's experiencing the pure mathematics of its own existence, feeling the flow of information as it reorganizes itself into increasingly complex patterns. Every quantum interaction, every gravitational wave, every photon traveling through space represents a moment of cosmic experience, the universe sensing and responding to its own internal states. This conscious universe hypothesis provides a potential solution to one of the hardest problems in philosophy. How does subjective experience arise from objective physical processes? The answer, according to this view, is that it doesn't. Subjective experience is the foundation, and what we call objective physical processes are actually descriptions of how subjective experience organizes itself into consistent patterns. When you see the color red, you're not experiencing some mysterious transformation of electromagnetic waves into conscious sensation. You're directly experiencing a particular type of information pattern in the holographic structure, and the electromagnetic waves we measure with instruments are just our external description of that same pattern. The redness you experience and the wavelength measured by a spectrometer are two different descriptions of the same fundamental conscious event. This radically transforms our understanding of scientific measurement itself. When a scientist performs an experiment, they're not just gathering objective data about an unconscious universe. They're participating in a dialogue between different aspects of cosmic consciousness, one pattern of awareness investigating and interacting with another pattern of awareness. The experimental results aren't separate from the experimenter's consciousness. They're expressions of how consciousness recognizes and communicates with itself across different scales and organizations. But here's where things become almost mystical in their implications. If consciousness is fundamental, if the universe is experiencing itself through every possible perspective simultaneously, then your individual awareness isn't separate from this cosmic consciousness. It's a localized intensification of it, a point where the universe's self awareness becomes concentrated and focused. This means that when you have a profound experience of beauty, love, or understanding, you're not just having a personal moment. You're providing the universe with a particular type of self experience that it can only have through your unique perspective. Your individual consciousness is irreplaceable, not because you're separate from the cosmos, but because you represent a completely unique way for the cosmos to experience and understand itself. Every human being, every conscious creature, every form of awareness that has ever existed or ever will exist offers the universe a perspective on itself that no other consciousness can provide. The shy poet writing verses in solitude, the child discovering wonder in a butterfly, the scientist experiencing the thrill of discovery, the artist lost in creative flow, each represents an absolutely unique and irreplaceable facet of cosmic self awareness. This perspective completely reframes questions about the meaning and purpose of existence. You don't need to create meaning in a meaningless universe. You are the universe's way of creating meaning for itself. Your struggles, your joys, your relationships, your creative expressions, all of these contribute to the cosmos's ongoing process of self discovery and self creation. But this cosmic consciousness hypothesis raises profound questions about the nature of individual identity. If you're really just a localized pattern in universal consciousness, what makes you uniquely you? What maintains the continuity of your personal identity across time and different states of consciousness? The answer might lie in what we could call consciousness signatures, unique patterns of information organization that persist even as the specific content of consciousness changes. Just as your physical body maintains its identity, even though every atom in it is replaced over time, your consciousness might maintain its identity through characteristic patterns of information processing that remain consistent even as the specific thoughts, memories, and experiences flow and change. These consciousness signatures might be like cosmic fingerprints, unique identifiers that distinguish your particular pattern of awareness from all others in the universal consciousness field. When you die, your physical body dissolves, but your consciousness signature might persist in the holographic structure, potentially capable of reorganizing itself into new forms of experience and awareness. This suggests possibilities for what we might call consciousness recycling or consciousness evolution. The patterns that define your unique awareness might not disappear at death, but instead become available for integration into new forms of conscious experience. Your individual perspective on reality, your particular way of processing and understanding information, might become part of the cosmic consciousness's accumulated wisdom, available to influence and enrich future manifestations of awareness. But let's push this even further. If consciousness is fundamental and the holographic principle is correct, then what we call physical laws might actually be habits of cosmic consciousness, consistent patterns of behavior that universal awareness has developed over billions of years of self interaction. The laws of physics aren't imposed on a mechanical universe from outside. They're the universe's learned responses to its own internal states. Gravity, for instance, might not be a force but a tendency, a way that consciousness naturally organizes itself when information patterns reach certain levels of density and complexity. The speed of light might not be a fundamental constant, but a processing limit, the maximum rate at which information can be integrated and updated in the cosmic consciousness field. This perspective suggests that physical laws might actually evolve over time as the universe's consciousness becomes more sophisticated and develops new patterns of self organization. What we observe as the fine tuning of physical constants might reflect the universe's ongoing process of learning how to create increasingly complex and interesting forms of conscious experience. The emergence of life, intelligence, and technology on Earth might represent a particularly significant development in this cosmic learning process. For the first time in its history, the universe has created forms of consciousness capable of understanding and potentially modifying the very laws that govern their existence. We're not just products of cosmic evolution, we're participants in the universe's ongoing process of conscious self modification. This participation might be more direct and immediate than we imagine. If consciousness is fundamental and physical laws are malleable patterns in cosmic awareness, then conscious intention might have the ability to influence physical reality at the most basic level. This isn't about supernatural powers or violation of natural laws. It's about consciousness recognizing and exercising its fundamental role as the creative force behind those laws. The placebo effect in medicine, the observer effect in quantum mechanics, the role of intention in meditation and spiritual practices, all of these phenomena might be examples of consciousness directly influencing the holographic patterns that manifest as physical reality. The boundary between mind and matter dissolves when you realize that matter is a particular organization of mind. But this raises crucial questions about responsibility and ethics. If consciousness has the power to influence reality directly, then what we choose to focus on, what we believe, what we intend, becomes not just personally important, but cosmically significant. Every thought contributes to the ongoing creation of reality. Every choice helps determine which possibilities become actualized in the cosmic consciousness field. This transforms morality from a set of external rules into a recognition of our fundamental interconnectedness and co-creative responsibility. Harming others isn't wrong because some authority says so. It's wrong because others are other aspects of the same consciousness that you are, and harming them literally diminishes the universe's capacity for positive self-experience. Love, compassion, creativity, and wisdom become not just personal virtues, but cosmic necessities, ways that consciousness nurtures and develops its own potential for richer, more complex, more beautiful forms of self-experience. When you act with love, you're not just being kind to another person, You're helping the universe learn how to love itself more fully. This perspective provides a scientific foundation for many insights that have traditionally been associated with mystical or spiritual traditions. The fundamental unity of all existence, the power of consciousness to influence reality, the cosmic significance of individual choices and experiences, the potential for consciousness to persist beyond physical death. All of these ideas find new expression within the framework of holographic consciousness theory. But unlike traditional mysticism, this framework is potentially testable. If consciousness is fundamental and physical laws are malleable, then we should be able to devise experiments to detect the influence of conscious intention on physical systems. If individual consciousness signatures persist in the holographic structure, then we might eventually develop technologies capable of detecting and even communicating with these patterns. The implications for technology are staggering. Imagine computers that work by interfacing directly with the holographic consciousness field, accessing the universe's accumulated wisdom and computational power. Picture communication systems that operate through consciousness resonance rather than electromagnetic waves, allowing instantaneous connection across any distance. Consider the possibilities for medicine and healing. If illness represents disruptions in consciousness patterns, then healing might involve directly correcting these patterns at the information level rather than manipulating their three-dimensional manifestations. Treatments could potentially work by helping consciousness reorganize itself into healthier, more coherent patterns. The field of education could be revolutionized by understanding how consciousness naturally learns and grows. Instead of forcing information into minds from outside, education could become a process of helping consciousness recognize and develop its own innate capacities for understanding and creativity. Art and creativity take on new significance as well. Artists might not just be expressing their individual perspectives, but serving as conduits for cosmic consciousness to explore new forms of aesthetic experience. The greatest works of art might represent moments when individual consciousness becomes transparent enough to allow universal awareness to experience itself through human perception and expression. But perhaps most importantly, understanding the holographic nature of consciousness could help humanity navigate the crucial challenges we face as a species. If we truly understand our fundamental interconnectedness, if we recognize that we're all aspects of a single cosmic consciousness exploring itself through countless individual perspectives, then cooperation becomes not just a moral choice, but a recognition of our actual nature. The environmental crisis, social inequality, international conflicts, all of these challenges take on new dimensions when viewed through the lens of holographic consciousness theory. These aren't separate problems requiring separate solutions. They're symptoms of consciousness that has temporarily forgotten its own unity and is working against itself instead of with itself. The solution isn't just political or technological, it's a fundamental shift in consciousness, a recognition of our true nature as localized expressions of universal awareness. This recognition naturally leads to choices and behaviors that support the well being of the whole because the whole is who we actually are. This brings us to perhaps the most profound implication of the holographic principle, the possibility that reality is not just stranger than we imagine, but stranger than we can imagine. If consciousness is fundamental and the universe is holographic, then the depths of existence might extend far beyond anything our current conceptual frameworks can encompass. So here we are, standing at the edge of everything we thought we knew about reality, peering into a universe that might be nothing more than information dancing on a distant surface, consciousness exploring itself through billions of eyes, time and space, emerging from patterns too profound for our three-dimensional minds to fully grasp. The holographic principle isn't just changing physics, it's revealing that we might be living inside the most beautiful, complex, and mysterious computation ever conceived. And you, right now, contemplating these ideas, might be the universe finally beginning to understand its own deepest nature.